Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for set matrix zeros problem. Let's look at the problem description. We are given an m by n matrix, and if an element is 0, then we have to set the entire row and column in which that element is present to 0. And we have to do that in place without allocating any additional space. So let's take a look at the example 1. So in this, the element at row 1 and column 1 is 0. So we have to mark all the elements in the column 1 and row 1 to 0. Okay. In the case of example 2, the element at row 0 and column 0 is 0 and row 0 and column 3 is 0. So in this case, we have to set 0 for all the elements in the first column, and we have to set all the elements in the first row to 0 and then all the elements in the last column to 0. The constraints for this problem are m is the number of rows in the matrix and n is the number of columns in the matrix. So the m and n value is ranging from 1 to 200, and each cell's value will be ranging from -2 to the power 31 to 2 to the power 31 minus 1. We need to come up with a constant space solution. Let's look at the approach to solve this problem. So we are given a 3 by 4 matrix in which 3 cells are having 0. So we have to set 0 for the column 0 and row 0 and row 2 and column 3. We are expected to solve this problem with constant space, but we can process the matrix multiple times. There is no restriction. Okay. So in that case, we can use the cells in the first row and the first column to store the information about whether the corresponding row and column cells should be set to 0 or not. Okay. So to begin with, we process the cells except the first row and the first column and check whether the cell has 0 value or not. If the cell has a 0 value, then we have to mark the cell which is in the same column at the first row. Okay. So this cell will be set with value 0. Similarly, the cell in the same row but at the first column will be set to 0. So this 1 will be changed to 0 and this 2 will be changed to 0. So this is done in the first traversal. Okay. So these cells are processed, and if the cell is 0, then the corresponding cell is set to 0 in the first row and first column. Okay. In the second traversal, we process the same set of elements. When each cell is processed, we check whether the corresponding cell in the same column at row 0 or the same row at column 0 has value 0. If that is true, then we mark this cell to 0. For example, when we process the cell 5, we see the cell in the same column at row 0 is having value 0. So then we mark it as 0. When we process this cell, we see this cell has 0. So we mark that as 0. When we process this 5, we see this cell has 0. So we mark that as 0. Except first row and first column, the rest of the cells are set with 0 depending on the value in the first row and the first column. Next, we have to handle a case where the top left corner cell is equal to 0. If that is equal to 0, then we have to mark the entire row with value 0. So starting from the second column, the rest of the cells will be set to 0. That's what done in this third step. Then whenever we process the row, we check whether the first column in that row has value 0. If that is true, then we set a flag to keep track of this information to true. So that indicates the entire column needs to be set with value 0. So that's what we are doing in the last step. Finally, if we look at this matrix, we see all the relevant cells are set with value 0. So that's what I have written here. First we initialize the rows and column variables, and then initialize the first call has 0 flag to false. Then we traverse all the rows in the board in the matrix. And if the cells in the first column is 0, then we mark that first call as 0 flag to true. Then we traverse each cell and then we check whether that cell has value 0. If it is 0, then we mark the first cell in the ith row to 0. The same way the first cell in the ith column to 0. Next, when we process the matrix the second time, except the first row and the first column, we process the rest of the cell. Whenever a cell is processed, we check whether the element in the same column at first row is equal to 0 or the element at the same row at first column is equal to 0. If that is either one of them is true, we set the value 0 to the current cell. Okay. Then in the third step, we check whether the top left corner cell, the cell at the row 0 and column 0 is equal to 0. Then we mark the entire first row with the value 0. And then finally we check whether the first call has 0 flag is true. If that is the case, then we have to set the entire first column with value 0. Let's look at the flowchart. Input for this procedure is m by n matrix. First we initialize the rows columns variable, and we initialize the first column has 0 boolean. Okay, so initially that boolean is set to false. Then we start traversing the elements in the matrix row by row, starting from row 0. First we check whether we visited all the rows. If so, we come out of the loop. Otherwise, we check whether the first cell in that row has 0. If that is true, then we mark the first column as 0 flag to true. Then we start processing all the cells in that row. Okay, so initialize the column variable to 1, and we check whether all the columns are visited. If not, we check whether the cell at the current row and column is 0. If it is 0, then we mark the cell which is present in the same row and the first column to 0. And then we set the cell in the same column at row 0 to 0. Okay, we repeat this for all the cells. Okay, so when we come out of this loop, we have the first column and first row set with the value 0 for the rows and columns which needs to be zeroed out. Next we again process the matrix. This time we process starting from row 1 and column 1. Okay, so first we check whether all the rows are visited. If not, we go ahead and process all the columns in that row. And so for each cell we check whether the cell in the same row at column 0 is equal to 0, or the cell in the same column at the row 0 is 0. If either one of them is true, then we mark the current cell's value to 0. We repeat this for all the cells starting from row 1 and column 1. Next, we need to handle the special case. If the top left corner cell at row 0 and column 0 is equal to 0, then we have to zero out all the cells starting from column 1 to 0 in the first row. That's what we are doing. At first row, we set 0 to all the columns in this loop. Then finally we check whether the first column has 0 flag is true. If this is true, then we should zero out all the cells in the first column. Okay, so that's what this loop is doing. Starting from row 0, we mark the cell at column 1 to 0. So when we come out, we have the matrix with the relevant row and columns are set to 0. Let's move on to coding. First I initialize the rows and columns variable with the number of rows and the columns in this matrix. Next, I initialize the first call as 0 flag to false. This is to keep track of whether any one of the elements in the first column has 0 value. Next, I process the elements row by row, and each time I process a row, I check whether the first element in that row, the element in the first column in that row, has 0 value. If so, I mark the first call has 0 flag to true. Then I process the rest of the cells in that row, starting from column 1. I check whether the cell at row I and column j is equal to 0. If that is true, then I mark the first cell in that row with value 0, and also at the row 0, the jth column cell also will be set to 0. Then again I process the cells in the matrix from column 1 and column row 1 and column 1. For each cell, I check whether the cell at row I and column 0 has value 0, and the jth column element in the first row also equal to 0. If either one of them is true, then I mark the current element's value to 0. Then the third step is, if the cell at row 0 and column 0 is equal to 0, then starting from column 1, the rest of the cells will be set with 0 in the row 0, the first row. So I mark all the elements in the first row with value 0. The last step is, if the first call has 0 flag is true, that means one of the cell in that column is 0, so we have to zero out all the cells in that column, the first column. Next, I am going to run the test cases. Oh, I missed the close parenthesis. Okay, let me rerun the test case. Okay, all the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. We are given 3 by 4 matrix which has 2 zeros. One 0 is at row 0, column 0. The second 0 is at row 0, column 3. We have to zero out the first column, first row, and the last column. Okay. So first we initialize the rows and columns, and the first call has 0 variable. So the rows is 3 and column is 4, and the first call has 0's flag as set to false. For the sake of simplicity, I'm going to do code walkthrough only for the outer loop in this case. So in the iteration 0, so we are processing the row at 0, and when we enter, the first call has 0 flag is false. Okay, and we check whether the element at the first column in that row is 0. In this case it is true, so we mark that as true. Okay, and then when we process this row, starting from the column 1, we check whether that element has 0. So in this element is 0, but we just set 0 again, and in the iteration 1, so none of the element is 0, so there is no change in the first column and the last column. And in the iteration 2, this row also do not have any 0, so that's why there is no change in the first column and the first row. Then next we enter the second for loop, wherein we process the rows starting from row 1 and the columns starting from column 1. Basically this part of the matrix we are processing. For each element we access, we check whether the cell at row 0 in the same column as the current element is equal to 0. In this case it is not, and when we process this element, here also this element is not equal to 0, so we are not modifying this. But when we process this element 2, so the cell at row 0 and the same column in which this element is present is equal to 0. So we mark that element as 0. Okay. And then next, when we process the row 2, again when we process 5, this first cell is 0, so we mark that as 0. Okay. Then we come out of that second for loop. Next, the third for loop, if the cell at row 0 and column 0 is equal to 0, then the entire first row should be 0 out. So in this case, iteration 0, we mark this as 0. We set this cell with value 0, and in iteration 2 we set this cell with 0, and in iteration 3 it's already zeroed out. Okay. Next, we check whether the first call has 0 flag is true. If that is true, one of the cell in the first column is 0. So in that case we have to zero out the entire column. So that's what this for loop is doing. So in the iteration 0, we zero out the first cell, and in the iteration 1 we zero out the second cell, and in the iteration 2 we zero out the third cell. So when we return, we have the first column, first row, and the last column is zeroed out, and that is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. The time complexity for this solution is order of m times n. So we calculate the time complexity in terms of the write operation, that is updating the cell with value 0. So if you look at, for this input, the number of rows is 3 and the column is 4. Okay. So there are 4 for loops in this procedure. So the first for loop performs 9 write operation, and the second for loop performs 6, and the third for loop performs 3 write operation, and the fourth one 3. So totally 21. So if the row is m and the column is n, then the first for loop performs m times n minus 1 write operation, and the second for loop performs m minus 1 times n minus 1 write operation. Third for loop performs n minus 1 operation. The fourth one performs m write operation. So if we add all of them, we get 2 times m times n minus m. So we take the dominating factor. So the time complexity is order of m times n. And the space complexity is order of 1 because we are not allocating any additional space, only the few variables. So the space complexity is order of 1. Thanks for watching this video. Have a great day.